Today we'll be starting a brand new unit on probability. Let's begin with probability and set theory. So we've got a few definitions and some notation to go over. First, a set. A set is a collection of distinct objects. So think about things that you might collect, whether those be, trading cards or stamps or coins. A lot of different people collect a lot of different things. So your collection would be your set. And each piece of your set, so each stamp that you have, each card that you have, these are elements. Each one of these is an element within your set. And how you would write this is use these brackets, kind of squiggly lines, and each element will go inside with commas separating each one. Now, if you're talking about an empty set or a null set, you're talking about a set with nothing inside of it. Here you'd use like a 0 with a slash through it, or you could use these brackets, just have nothing inside. And then the set of all elements under consideration is the universal set. So maybe you're collecting, trading cards like I had mentioned, and you have a pretty good set of your own, but you don't have one of everything yet. One of everything might be the universal set. What you have is a subset of that universal set, and each card, each rare card that you have is an element in your collection. It's an element in your set. So here are some examples. Let's say we've got a set of prime numbers less than 10. We'll call it A. So prime numbers less than 10 would be 2, 3, 5, and 7. A equals, use a little squiggly line there, 2, 3, 5, 7, and then close it off. The number of elements in the set is 4. B is the set of even natural numbers less than 10. So that'd be 2, 4, 6, and 8. 4 items there. C is the set of natural numbers less than 10 and multiples of 4. So it has to meet both conditions now. So that's 4 and 8. 2 items there. D is the set of all odd numbers less than 10 and divisible by 2. Well, in order to be odd, it can't be divisible by 2. Therefore, I would say that D is the null set or it's an empty set. There's nothing there. So there's 0 items. And the universal set that we've been talking about here might be the natural numbers less than 10. So the universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9. And then there's 9 items in the universal set. I talked about subsets earlier a little bit with collections of cards and such. A subset is a set contained within another set. So in that example, C might be what cards you have, and B might be what cards, maybe your friend has been collecting longer than you have. So you've got a good portion of what they have, but neither of you has every single card. So you have a subset of what your friend might have, and both of them are subsets of the universal set. An intersection, this is what items belong to both sets. So if you've got 2 sets, set A and set B, the part that they share, the part that overlaps, would be the intersection. Here, for a subset, I write a U sideways. For an intersection, I kind of write a U upside down. And then the easier one to remember, union, since it starts with U, this would be right side up. This is just all of A and all of B combined. And whatever overlaps, I only count it once. Lastly, the complement is what is not part of the set. So if I'm saying A complement, I'm saying what is not part of A. So here are some examples. Let's say I've got the sets A and B. A is 2, 3, 5, 7, and B is 2, 4, 6, and 8. What is the intersection of A and B? So like a road, okay, maybe you've got like a road that goes this way, and then you've got another road that goes this way. The intersection is the part that they overlap, okay, where you've got this section that is part of both roads. So the intersection here is 2. That's the only number that's in both A and B. So I would write this a little squiggly bracket like so, put a 2 there, and close it off. The union, however, is everything. So it's all of this road and all of this road, and the intersection I only count once. So even though the intersection of A and B had this element 2, I'm only going to count that one time when I write the union. The union would be 2, 3, and then let's do 4, 5, 6 is over here, 7 over here, and 8. So all of the elements in A and all of the elements in B, here I've organized them nicely, 2, 3, 4, 5, 6, 7, and 8. What about sets C and D? C is 1, 2, 3, 4, and D is 1, 2, 3, 4, 5, 6, 7, and I've also got E here, 8, 9, 10. What relationship do sets C and D have? C is 1, 2, 3, 4. D is 1, 2, 3, 4, 5, 6, 7. So everything in C is in D. C is a subset of D. I would say C is a subset of D. In words, say C is a subset of D. What is the intersection of sets C and E? C is 1, 2, 3, 4. E is 8, 9, 10. And the intersection is what overlaps. There's actually nothing that overlaps. So the intersection of C and E would be the null set, or you could say the empty set. So how does this play into probability? Well, for probability, we're going to be talking about different parts of the same set. Let's say that we've got this. You roll a 6-sided die. Event A is rolling a prime number, and event B is rolling an even number. Answer the following questions. How many possible rolls are there in total? Well, if it's a 6-sided die, there's a 1, a 2, a 3, 4, 5, and 6. There are 6 possible rolls. All right, what is the probability of event A? Event A is rolling a prime number. So of these, we have the following prime numbers. We've got 2, 3, and 5. 1 is not a prime number, 4 is not a prime number, 6 is not a prime number. So the probability of event A, first we have to define probability. Probability is the number of ways an event could occur over the total number of possibilities. So let me write that down. Probability of an event is equal to the number of ways the event could occur over the total number of possibilities. In this case, there are 1, 2, 3 prime numbers over 6 possible rolls. So the probability of getting a prime number, the number of ways the event could occur, I could get a 2, a 3, or a 5. There are 3 ways that this event could occur over 6 possible rolls. So the probability of getting a prime is 3 over 6, which I could reduce to 1/2. And what is the probability of the intersection of events A and B? So let me go back and read what A and B are. A is a prime number, and B is rolling an even number. So the intersection would be a prime number that is also an even number. That's just the number 2. So I would say probability of A intersect B is one way for this to happen. That's rolling a 2 out of 6 possible rolls. All right, let's keep going. And this time we'll be using the complement of an event. So earlier we said the complement is what is not part of that set. And what you might have noticed is that all probabilities add up to 1. So a 6-sided die, what are all the things that could happen? Getting a 1, a 2, a 3, a 4, a 5, or a 6. Well, the probability of getting a 1 is 1 out of 6. The probability of getting a 2 is 1 out of 6. Probability of getting a 3 is 1 out of 6, and so forth. So there are 6 of them that are all 1 out of 6. They all add up to 1. Flipping a coin. Many people say, what is the probability of flipping a coin to be heads? People would say 50-50. Well, what they're really saying is 1 out of 2, right? 50%, 1 out of 2, because there's 1 heads out of heads and tails, 2 sides. But the probability of flipping a tails would also be 1 out of 2. So those combined would be 2 out of 2, or 1. So knowing that, sometimes it's easier to find what you don't want and then subtract that from the whole rather than finding what you do want. Here's an example. Let's say you are given 2 distinct 6-sided die that are both fair. One is red and one is black. What is the probability of rolling both dice such that the dice show different numbers? That is, what's the probability of not getting doubles on these dice? So we've got a red die and a black die. And here are all the things that could happen. I could get, let's read off the black die first and then the red die. I could get a 1 and then a 2. That's not a double. I can get a 1 and a 3, a 1 and a 4, a 1 and a 5, or a 1 and a 6. And then moving on to 2 for the black die, that'd be 2 and then 1 for the red. I have to skip 2, 2 because those are the same. I could get 2, 3, 2, 4, 2, 5, 2, 6. Okay, and then moving on to 3, 3, 1, 3, 2, not 3, 3, 3, 4, 3, 5, 3, 6, and so forth. The problem with this method is I would have a lot of writing to do and a lot of counting. Luckily, I had a computer, so I was able to just kind of plot all this for you. And then you would have to count all the ones that I've shaded in green here. You'd count them up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so forth. And then you end up finding that you've got 30 of these. There are 30 ways to get 2 dice to not read the same number out of 36 possible rolls. So the probability would be 30 out of 36, or you could reduce that to 5 out of 6. That's one method, and it works, but it does take some time. The other way to do this is to do the complement. I noticed that there are 30 possibilities, meaning that there are 6 possibilities that are not, that are not what I want. I don't want a double. So then, just counting those 6, I can get a 1 and a 1, a 2 and a 2, a 3 and a 3, a 4 and a 4, a 5 and a 5, and a 6 and a 6. There are 6 possibilities where I get a double, which is what I don't want. But if I know that the whole must be 1, the whole must be 1, or you could think of it as 36 over 36. I could simply subtract what I don't want. I could subtract 6 out of 36, which is the probability of getting a double, to find what I do want. 1 minus 6 over 36, or 36 over 36 minus 6 over 36, would be the same 30 over 36, or you could reduce that to 5 over 6. And then when you notice, you could add these two things together. The probability of getting a double would be 1 out of 36. The probability of getting anything but a double would be 5 out of 30, or 1 out of 6, and then 5 out of 6 for not getting a double. Add those together, it's 6 out of 6, or a whole 1. If you kept it so that the total possibilities matched the total number of rolls, then getting a double would be 6 out of 36, and then not getting a double would be 30 out of 36. Add those together, and there's your whole 1, which is 36 over 36. Hope this helps out. The next section, we're going to be talking about permutations, and then after that, some combinations, and more to come later.